Wait. You guys think about it. I can't find my clicker. There's an iClicker. Start, please. Do you have one of those clicker for me? Oh, am I not finding it? Sorry. This is the last thing. Oh, thank you. The last thing I did last time over here. And what I'm saying is that tell me what is the inequality as it is. So this is as it is. That one. What is y between? Which one's lower, which one's higher? What is x between? So if I draw y equal to x, that's this one, right? If I draw y equal to 1, that one, what is the arrow going from what to what? X to 1. Is arrow vertical currently? Arrow vertical or horizontal? Wait, what is the variable inside? dy. dy is vertical. dy is vertical. So inner one is vertical. The arrow is the vertical. Still the currently, not how I'm going to do it. Vertical. Right now it's vertical. Currently, it says currently. Oh, it doesn't say currently. Now it says currently. Right? Vertical. And then does it match from 0 to 1? Yes, it matches. That's the shaded area. Now it's asking you to change the arrow. When I change the arrow, which way? This way. Now tell me what is min and max of y? What is min and max of x? Where does x start? Where does x end? X equal to y. Where does y start? Where does y end? 1. Now, which one of those match this? Libby, we started from currently is that shape. Oh, did you just walk in? Okay. Currently, we have this. Hey, what's up? No, look over there. What is x supposed to be between? 0 and 1. Which one has, yeah. There's only one that has x is between 0 and y. Which one x is between 0 and y? A. Fair game? We're good? Can I start counting? 4, 3, why is it 148? 2, 1, 0. Hold on. A is correct answer. So again, this means that dx goes from 0 to y and dy goes from 0 to 1, whatever f is, tan of y squared. And the reason that we switch is because integral of tan of y squared dy is what? Can anybody tell me what's wrong with that? The one more reason, it's not you don't want to do that. The only way to do it is with computer. Yes, you cannot do U substitution, so you switch the order, it becomes a U substitution. This is non-elementary. Non-elementary means I have to use Wolfram alpha. Or actually, if you know more other programs. But Wolfram alpha is cheap and nice, and cheap means free. Okay, so far so good. Now so far, all I've talked about are the basically either y simple, okay, either y simple or x simple, right? What if it's neither? What if not? What if it is not the region, I mean, the region that we're integrating over? Not y simple or x simple. What do I do after that? So how we go about this, let me start with this, the property of integration. We had a version of this in Calc 1 and Calc 2, but now it's more interesting. So let's say a region is like this, and almost, right? It's not quite, it's neither x, I mean, this one you can manage stuff with it. I didn't draw a very good one. But let's say a region is neither x simple or y simple. What you do is you can, for any region, you can divide the region D into D1 and D2, where D is equal to D1 union D2, and D1 intersecting D2 only contains boundary points. So it doesn't have anything inside. So this is inside the boundary curves. So the intersection is a boundary curve. Could be boundary here or boundary out here. So if you have such a division, then you can write the integral over region D of f dA. Do you guys remember, we start with this notation. What does this mean? What does dA mean? It's either dx dy or dy dx. It's just area element. When I don't know the order, that's how I put it. And D means the region of integration without the setup. Right? So when I don't have the setup ready, I typically use this. Region of integration. So this can be written as over the first region plus over the second region. It's one of the properties of double integral. I can find if I can divide it in two regions that are not too much of intersection, here only have the boundary in common, then I can write the integral like that. Why is that? Because then I can take a non-simple region and divide it into two simple regions. Here's the, oh, my bad, covering this up. This is the region of integration. Is this x simple? Draw an arrow from here to here, and then from here to here. Neither of them give you x simple. The two of them are not from the same function. Now, if I go from bottom to top, sometimes I touch that curve, sometimes I touch that curve. Neither x simple nor y simple. And so therefore, this is going to be on the exam. I'm pretty sure it's going to appear on the exam. So let's talk about this. Neither x simple or y simple. But the fun part of it is that I can divide it in two pieces such that both pieces are one-way simple. And here's what I do first. If I break it from that point down, then I will have two triangles that are y simple. So that's what I'm doing, breaking it down from the top to bottom. I have R1 and R2. Are these y simple? They are y simple, correct? Now, what I do is I compute the integral in each region and add them up because I know how to do it in the simple regions. It's very similar to Calc 2. So how do I do that? Simple region 1, I can see that the x value of region 1 goes from 1 to 3. Everybody agrees. Region 1, x goes from 1 to 3. Region 2, x value goes from what? 3 to 5. Both regions are y simple. Now let's set this up. But to set this up, I have to find the equations of the line. Now, my bad, how do I find the equation of this line? Slope. What is the slope here? 1. And then if I continue it over here, the y-intercept is 0, 1. So the equation is y minus 1 equal to slope, which is 1 times x minus 0. Agreed? That is this equation. I said y simple, correct? So I have to solve for x or y inside. Y simple, I have to solve for y. Right, so I have y simple. Sorry about that. I have y simple, so inner one is with respect to y, and that's in f. The function is not specified, so you don't have to integrate. So I have f dy, and then outside is going to be dx. I know dx goes from 3 to 5 for this one and 1 to 3 over here. I just have to find the bounds for the inner one. And inner one, I know the upper in terms of, I have to solve bounds for this variable, for y, and also here. So over there, I found y is equal to what? X plus 1. So I put in on top x plus 1. Look, top of the arrow is y equal to x plus 1. What is the bottom of the arrow? Let's compute that. What's the slope of the bottom? Negative 1/2, everybody agrees? And I have a point right here, 5 and 0. So how I compute it is I'm going to say y minus 0 equal to negative 1/2 x minus 5. Then if I solve, I get y is equal to negative x half plus 5 half. So that would be the bottom for both of these. See, both these arrows, let me draw my arrows a little bit more prominent. There we go. Both these arrows start at what line? Y equal to negative x half plus 5 half. So both of these are 5 half minus x half. Over there, I end up with x plus 1. Over here, I have to compute again. How do I compute? What's the slope? You can use 2 points to find the slope also. The slope is negative 2, right? And then I still have that point, so I have y minus 0 equal to negative 2 times x minus 5, and it solves to be that. And so y equal to negative 2x plus 10. Everybody okay so far? We're good? Continue to the second part. Now, what I'm saying is that this shape also can be broken into two x simple, right? So where should I divide to make it x simple? At y equal to 2, right? So at horizontal line, y equal to 2 gives me x simple. So that's what we do. Now we have R1 down here and R2 over here. What are the values for, what is the bounds, y bounds for R1? R1 is down here. 0 and 2. And then R2, 2 and 4. And then when I want to set it up, I'm trying to do this direction. That's the direction. Do you guys notice that both arrows end up at the same place? Yeah, both arrows are ending up at the same place. Again, horizontal means inner is dx or dy? Dx. Then it's dy. And over here also dx, then dy. I'm making both of them are horizontally simple. Now, for this one, I know dy is from 0 to 2, and this one is 2 to 4. Okay. For the one on the bottom, I end up at this line. This line was what? It was y equal to negative 2x plus 10. If y is equal to negative 2x plus 10, what am I supposed to do? Solve for x. So x is going to be 10 minus y divided by 2. Agreed? I took the 2x to the other side, brought the y here, divided. And so the top for both of them are 10 minus y divided by 2. Now, the bottom for region 1, if I solve y equal to 5 minus x divided by 2, I get 2y equal to 5 minus x. I get x is equal to 5 minus 2y. So the bottom part right here is x equal to 5 minus 2y. And then the bottom one part for that one is easy. I can solve for x and it's y minus 1. So this is x equal to y minus 1. Both of these are okay. I found the two and I have to add them. You can use this. This is a solution. Or you can use this and this is a solution. Don't add 4 of them together, just 2. A pair. Fair game? You guys are okay? You survived this one? Okay. Why? You didn't survive this one? Okay, barely, but he did. Okay, this is good. So if we survived it, it's all good. Now, what if I get something like that messy? How many simple regions are you guys going to divide this into? Yeah, I can. Here's the funny part. I'm not going to do it all the way. This is an easy one. If I do this one region, and then another region, this one is the horizontally simple, and over here another horizontally. So I can, if I want to not solve a whole lot, because that's y equal to, this is x equal to, and this one is also x equal to, I can nicely have 3 regions, 2 of them horizontally simple, 1 of them vertically simple. The inner one. Arrow is always for the inner one. Arrow tells you, this is mean the inner is dx, dx, dy. If that's the, and so here I can see arrow makes it horizontally. If I look at this region horizontally, simple. And I can do vertically simple, it's complicated. Vertically simple becomes complicated. It is vertically simple, but not the good one. That's what I'm saying. And then over here also, one way is easier, the other one is more difficult. So 3 regions. But also, let's think about this. Can I make this any easier than that? Can I do this into 2 simple regions? But then, basically, I can have this region like that, and this region over here like that. The only difference is that over here I have to, so can everybody see this is 2 horizontally simple regions? What do I need to do in terms of functions? Solve for x because it's horizontally simple. If I have inside dx and outside dy, so let's say this is region 1 or R, and then region S, and then we're going to add them together. And so for dx, I have to solve, the upper is y minus y cubed, but the lower I have to solve in terms of x. How do I solve for in terms of x? So first step, square root. Plus minus square root of y equal to x plus 1. Then x is equal to 1 plus minus square root of y. Okay, now I have to decide if it's positive or is it negative. Which one is it? So if I plug in let's say, if I plug in 0, I should get there is a negative sign. That's the problem. If I plug in 0 for y, that's 0 for y. I should get negative 1. But that doesn't tell me a whole lot. If I plug in 1 for y, I should get x is equal to 0. So is it positive or negative? Positive, negative 1 plus 1. So how did I do that? I checked, and I tried with the easy point, negative 1 and 0. That didn't work. Then I checked with 1 and 0 and 1. So point 0 and 1 tells me that the x equal to negative 1 plus square root of y is the correct one. And so I put in negative 1 plus square root of y. And then what is the bounds for y in here? 0 and 1. And then what about s? S starts at, dx in s starts at negative 1, ends here. And the y starts at negative 1 to 0. And so you add them together and you get the answer. But why did I do this one? Sometimes you really have to solve stuff like that. And then if you don't know between plus and minus, plug in a point. Plug in a point to see if it's plus and minus. Sometimes you need to plug in 2 points because the first one doesn't work. Don't get discouraged too quickly. Dig at it. That's a fair game. Okay, so that's that. Your turn. It's been a while. Should I come up? Mm-hmm. How's it going? Okay. How's it going? Okay. Should I go back? Should I go back? Did I come up too much? I lost my call. Hey, what's up? Okay, so here's the thing. Here's when that little information comes in handy. Absolute value of x is really not elementary. It's considered to be piecewise defined. Very good question. Thank you. Absolute value of x in mathematics, we always consider it to be a piecewise defined. It doesn't appear in that list. That's your sign, right? Piecewise defined. Yes.
If you split it into two degrees along the y-axis, couldn't it also be considered horizontally simple?
Yes, but it's just not given in that option.
Like I didn't think that was.
Yeah, that was not an option, but it actually you can do that. Okay, may I? Counting down, 4, 3, 2, 1. Faster, Nick. Okay, 0. B is the answer. And so you break it down into these two pieces, and they're both vertically simple. Very good question about the absolute value. Thank you for doing that. Now, I want to move on to the properties of double integral, so I can start triple integral. Have we had fun with double yet? I think it's pretty straightforward, right? But I mean, that's points, right? So, briefly, if I want to shorthand this, I would write this. Integral over region D of a sum of two function, double integral of sum of two function. What are you expecting to happen? By the way, the one with the region I already did, so I'm not going to redo it. Oh. That was a criminal act. Now, what if I have k multiplied? You guys know this, right? These are not surprise to you, is it? Right, this one also. Fair game? Then, let's say f is less than g on for every x and y in D. Can I say that this is less than equal to this? That's another property. I kind of missed the f of x and y, g of x and y. It's just easier to short note it. But the actual thing is f of x and y and g of x and y. Fair game? What else? Oh, this is interesting also. If we are saying the volume is between the volume over D between F lower and G upper is integral D upper is G, right? G minus F dA. So if I have two surfaces, one on top, one on the bottom, top is called what? G, the bottom called F. My two palm of the hands, two surfaces. So if I want to find the volume between these two, basically my height doesn't come from one function. My height comes from the difference between the two. The z of the difference between the two. That's what this is. Not next week, but the week after that, at least there's an example. Oh, now next week you have an example of that in lab. Example in the lab. So now, fun. You guys tell me, what is integral a to b of 1 dx? What is that in geometric view? It could be area of a rectangle like this, right? So what is the width of the rectangle? 1. So it could be the area of rectangle 1. But also, b minus a, what is it in here? The length of the length of a line segment. Yes, I can interpret it as area, but also it's the length of the arc, the other one, line segment, not arc segment. So now I'm going to twist this for you. What if I have this? Oh, sorry. What if I have this? What is this? What is this? It actually ends up to be area. It's the volume over d below z equal to 1. We always know that this means that area d times 1. So that is area d. When I get to the triple integral, I do that again. What are you expecting triple integral of 1 be? Volume of the domain. So one integral of 1, length of the line segment. Double integral of 1, area. Triple integral of 1, you haven't seen it, but it's going to be equal to volume. Even though everything we did with the double integral, we called it volume. But it's not triple integral also, if I integrate 1, is going to be volume. So that said, the last very important one is the F bar. You guys are consistently, I cannot tell you how important this is. The double integral, triple integral, when you actually take the real statistics. When you take the real statistics, which requires Cat 3, double integral and triple integral over and over and over again. So make yourself comfortable. But one of the things that you want to know is the average. In statistics, you want to know average. How do I find average of the function f? So average of f over region D. That is equal to the double integral of f on region D over the double integral 1 dA over D. So you sum it up over the region, right? You sum up everything over the region. Then you divide it by the area of the region. It's always when you're averaging it, you're dividing it by quantity that you averaged over. And the last one is interesting also, but I'm not going to even write it down. It's not. The last property. It's sort of two too easy to draw from the other one. So I mean, okay, so let's do an example with an average. If I want to find the average over, average what function? What's the integrand here? That's the integrand. Integrand is that. I'm finding the average of that. And you guys know the denominator in average is what? Denominator is exactly the area over T of 1 dA. And that is the area. What is the area of this triangle? 4 times 2 divided by 2. 4 times 2 divided by 2, which is 4. So I really don't need to double integral that. And just use this. Now, how do I set up the numerator? X simple or Y simple? Should I do X? They're both. It just feels like this would be a better one. So I let you guys do the other way, because the other way is actually, if I do X simple, it causes me trouble. I have to do trig substitution. So I actually like Y simple. What is this? Y equal to 1/2 of X. Agreed? So the integral on top is 0 to 1/2 of X. And then what is X running? 0 to 4, right? And don't forget the 1/4, and that's the average. Of what function? X squared plus 9, which is going to be 1/4, 0 to 4 of X squared plus 9 times Y, 0 to 1/2 of X dx. What? 1/4 is the area of triangle, yes. And then you end up with 1/2 of X. Somebody at the, just tell me what kind of a method do I need to use here? Method? What is U here? And du 2x dx. And then, and the bounds, if I have x equal to 0, u is 9. If I have x equal to 4, u is 25. Okay, so and then you set it up as 1 over 16? No, 1 over 8. Now, 1/2, 1/8, another half. So I have 1/16 of integral from 9 to 25. And I said square root of u du. And then you solve. I'm good. I'll let you guys finish it. Fair game? Okay, so let's see if I have anything fun here. No, I forgot. We don't have fun here. What? What? There was one? No, we're here. Okay, how about if I let you out 2 minutes early? Okay. Yes, I kind of want to finish this on Monday. I want to finish triple integral. So let me tell you some stories then. Little bit. So first of all, I want to talk about triple integral and what the meaning of this thing is. And then we talk about Fubini and rectangular prism. Then we set up a lot of beautiful 3D pictures. And when we set up, the chances that you make error exponentially decreases if you can read a 3D picture. That's what I'm saying. That's the, I don't do anything but the 3D picture. So what was the domain in one integral? It was a line segment. Was a line segment. What was the domain for double integral? Region. What is the domain for triple integral? Oh, by the way, I gave you the, and D is not a good candidate. We typically use W. It's going to be solid. What you do, when I tried to teach you the double integral, what do? I showed you a region in 2D, and then I created a volume over it. So now a region in 3D creates whatever analogous to that into what D? 4D. So it's difficult to see that, right? So you're basically, your height is in 4D. That's fantastic, right? So now, what is happening though? A lot of times, guys, I'm letting you out 2 minutes early, so can we like at least respect that and listen to me for the next 6 minutes, right? So what I'm saying is that imagine we always start with the rectangles and rectangular shapes. So I'm starting with the rectangular prism. Then I get to funky business solid for domain, right? First we start with the rectangular. What we're doing for rim and sum, we're breaking it into little prisms. Do you see all the little prisms? So we find that's the dv. That's delta x times delta y times delta z. Then you multiply that by the w that is not in the picture. That's the height in the fourth dimension. But it's no more than that. Everybody in this class knows what density means. Let's say mass density. Everybody knows that? Have you all seen mass density? So imagine you're working on a volume and the mass density changes from point to point. It's really not, if I want to graph this, it would be in 4D. But it's very sensible when I think about mass density over the volume here. So the mass density is a function of 3 variables. I multiply mass density by each one of those little ones. And I get the mass for each one of those little ones. And then I sum it up with the triple integral, and I get the mass for the entire thing. Fair game? It could be the mass density, it could be the charge density, it could be, what else do you guys have in your areas? Nothing? But the density? No density? I'm sure you guys have more than that. What's that? It is a story time, right? It's a story time. I'm just holding you hostage to listen to my story. That's all it is to it. You're hostage to listen to my story. But here, so what is happening is that you have, when you're doing a triple integral of f, dv, that's a notation. Please write this down. dv for, this is dx, dy, dz, right? And that's a solid. Sorry, was I too high? Was I this way the entire time? No? Oh gosh. can somebody please remind me if I'm like that? Because I sometimes don't look up. Sorry about that. So when I have something like this, right, what do? It's basically, let's say it's not even F, it's the density. For density, you guys usually use this, right? Sigma. Have you seen sigma before? Okay, so the sigma, you will have delta x, delta y, delta z times sigma x I, y, yj, z, k, and then you sum it up 3 times because they're j equal to 1 to n and k equal to 1 to l. And this is the Riemann sum. And then you take the limit as n goes to infinity, m goes to infinity, l goes to infinity. So you're summing it, you're doing the Riemann sum, and then you're summing it up. And you're taking the limit, sorry, the other way. Riemann sum, then you're taking the limit. Okay, you guys go home. That's okay. I gave up. Oh, yeah. Well, look at this. This is when I take the integral over 1 is volume. Goodbye. There's no way to win over you guys. Enjoy your weekend. I kind of wish I had done more. Yes. So if you go in there, there's a door on your left. If you go out that way, then you can get out entirely. But if you go that way on your right, there's a door. If you go this way, there's a door on your left. Hey, are you my student? Yes. You never talked to me before. Tell me, what's your name? You want to write it down? So how do you say it? Trunk. Trunk. Oh, trunk.
Can you remind me what defines a function as a simple region?
Oh, the simple region in 2D. Simple region in 2D or 3D. So if I have a simple region, either y simple or x, you have to be able to draw an arrow from one to another, and you always stay on one elementary function at the bottom and one elementary function on top. And then if you, what happened to you?
I fractured my wrist.
Oh,
Yeah,
that's not fun.
I was just asking if I could get some of the iClicker points, like excuse that I missed because I missed lab on Wednesday.
Okay, can you watch the video and fill out the lecture notes?
Okay.
Is that your dominant hand?
Yes, yeah.
So you have dominant hand is okay.
Yes.
Can you write in there and then send it to me and I excuse you?
Okay, thank you.
I'm so sorry.
No problem.
So and here, see, always the same elementary function, same elementary function. So both, this is vertically simple, this is horizontally simple. And then I define this in here also differently.
So long story short, the arrows have to cross both of the functions.
Yes, it goes from, so inside from one to another, but it's always the same one. But if I do it this way, look, do it this way, it goes from different ones to different ones. Okay? Okay, yes. Nefemin. Okay.
Just a quick question. This is on the test. Midterm register. Is having it in this form and not replacing these x, x, y, z.
So how much point did it give you?
It's got a 1 point for this. Even though, I got a point off on this one.
Oh, point off is right.
Really?
Yes.
Because like in the solution set, this form was boxed in as one of the answer choices. It was this form and the form where you substituted the constants with the 6. They were both boxed in on the solution set. I'm assuming
That was my mistake. But I mean, the rubric said you have to go all the way to there.
substituted. Okay.
Yes. Just 1 point, right?
Yeah,
Okay, just 1 point is
Yeah,
right.
makes sense. It's on the-
And I want you to remember that because soon enough, I'm going to ask you to do that. If you leave it like that, you cannot compute.
Okay.
That's important. That's why we kind of emphasize on it.
That's right.
Okay. You got a good grade, didn't you?
Sure. That's right.
Awesome. Okay.
Yeah.
I thought it was a good grade.
I mean,
I kind of
that's
looked up. Okay.
let's see.
I kind of know it approximately.